This is the OCR GCSE 9-1 Maths Paper 3, which is a foundation paper and it's from the June 2018 series. Question number 1, Part A. Write down the mathematical name of this triangle. Choose from the list in the box. Here we have two sides of equal length and therefore we have an isosceles triangle. Part B. Write down the order of rotation symmetry of this regular octagon. Well, we have a regular octagon, so the order of rotation symmetry is 8. Question 2, Part A. Write down for the first part 3091 rounded to the nearest 100. So, if I take a look at this 9 in the tens column, because that is 5 or greater, I need to round this 0 in the hundreds column up to the next digit. So I have 3100. Next we have to write 3% as a decimal. To find out what 3% is as a decimal, that is the same as 3 divided by 100, which is 0.03. So we have 0.03. Next we have the cube root of 27. We can use our calculator to work this out. The cube root of 27 is 3. Part B. Complete the statement below using a number from this list. Well, we have -2, 0, -6 and 6. -5 is greater than one of these numbers. We can think of this to be temperatures. -5 is warmer than -6. Part C. Write the following numbers in order of size, smallest first. So what we can do is write each of these to 3 decimal places by adding in a placeholder of 0. So we've got this 0.4 and then we add on 2 zeros to it. And we've got this 0.5, we add on 2 zeros to it. We've got this 0.06, we add on 0 to it. We've got the 0.444 and the 0.46. Let's add a 0 to it. So, now that everything is to 3 decimal places, we can now compare. So, what is the smallest? Well, that is this 0.060, followed by the 0.400, followed by the 0.444, followed by the 0.460, followed by the 0.500. So what's the smallest number? Well, that is 0.06, followed by the 0.4, followed by the 0.444, followed by the 0.46, followed by the 0.5. Question number 3, Part A. We have to calculate 3.6 divided by 1.2 subtract 0.3. We can use our calculator to work this out. So, we have the fraction button, we've got 3.6 on the numerator, 1.2 subtract 0.3 in the denominator, we end up with 4. Part B, we have to work out the square root of 12.25 cubed, correct to 1 decimal place. So, if we use our calculator to work this out, we have the square root of 12.25 cubed it turns out we get a value of 42.875, which we need to write to one decimal place. So if I was to write this to one decimal place, we end up with 42.9. So we have 42.9. And this is to one decimal place. Question number 4. This grid shows a horizontal line going through the point A. And what we have to do for part A for the first part is write down the coordinates of the point A. Well, we go 4 across and 3 up. So our coordinates are 4, 3. Next we have to plot the point -2, 3. So we have -2, 3. That point is over here. For part B, we have to write down the equation of the horizontal line going through point A. You can see each y coordinate is the same on this line. Each y coordinate is 3. So the equation of the line is y equals 3. Question number 5. Tea biscuits can be bought in packets of 20 or packets of 24. All biscuits are identical in size and quality. 20 biscuits for £1.50. That is our option A. And we've got 24 tea biscuits for £1.80. That is option B. Nada says the packet of 24 biscuits is better value for. Is Nada correct? Show how you decide. Well, let's work out the price per biscuit with option 1. We've got 150 divided by 20, that's 0.075 per biscuit. And if I take a look at option B, that's 180 divided by 24, which is 0.075 per biscuit. So what do we see here? Well, we see that they have the same value per biscuit. So Nada is incorrect because they are equal in value. Question 6. You are given that 5y equals 4x. Part A, find the value of y when x is 10. So, when x is 10, we have 5y equals 4 multiplied by 10. So we have 5y equals 40, and if I divide both sides by 8, y is equal to 8. We now have to find y in terms of x. So all we have to do here is divide both sides by 5. So y equals 4x over 5. Question number 7, part A. Frances has 3 cards, ace, king and queen. She shuffles these cards and deals them one at a time. For the first part we have to list all the different orders in which she can deal the cards. One possible order is already shown in the table. You do not need to use all the rows. So we've got A, K and Q for the first, second and third cards respectively. We could have A for the first, Q for the second, and K for the third. We could have K first, then A second, then Q third, or we could have K first, Q second, and A third. Or we could have Q first, A second, K third, or we could have Q first, K second, and A third. Next, we have to find the probability that in the 3 cards Frances deals, the king is dealt immediately after the queen. So we want queen followed by king. Now, how many different combinations do we have altogether? We've got 6 of them. So our probability will be out of 6. And how many do we have where we have queen then king? So we have the king dealt with immediately after the queen. So we have this one and this one. So we've got 2 of those. So we've got 2 out of 6. And if I work this out, that simplifies to 1/3. So we've got 1/3. Part B, a counter has 3 on one side and 5 on the other. Lena flips the counter. She then picks one of these 3 cards at random. We've got subtract 1 times 2 plus 4. Lena puts the card next to the counter and works out the answer. For example, if we have the 5 and then we multiply it by 2, we get an answer of 10. We have to find the probability that Lena gets an answer less than 8. You must show you're working. So, we could either have our coin showing a 3 or a 5. So, if we've got the 3, one thing I could do with this is multiply it by 2. We could subtract 1 or we could add 4. So if I subtract 1 from it, 3 subtract 1 is equal to 2. Or I could take this 3 and then what I could do is multiply it by 2. So if I multiply it by 2, I get 6. Or I could take this 3 and then I could add 4 to it. And that gets me 7. Or I could start off with this 5. I could subtract 1 from it, and doing so, I get 4. I could start off with this 5, then multiply it by 2, and that will get me 10. Or I could have this 5, I could then add 4 to it, and that gets me 9. So, let's think, what do we need to do? We need to find out the probability that we get an answer less than 8. So we want probability of getting an answer less than 8. Well, the 2 is less than 8, the 6 is less than 8, the 7 is less than 8, and so is this 4. So, the probability that we have less than 8, that's equal to 4, because we've got 1, 2, 3, 4 numbers which are less than 8, out of a total of 6. So if I work this out, I get 2/3. Question number 8. 2 groups of students go on a water sport holiday. Each student chooses one activity. Students in Group A choose from diving, swimming, paddleboarding, and kayaking. Their choices are to be shown in a pie chart. Part A, complete this table for Group A. So, we have 5 students representing 60 degrees. What we can do is find out what one student would be represented by. So one student will equal 12 degrees. Now we know that angles around a point sum to 360, so we can find the angle for paddleboarding. So, if I do 360, subtract 60, subtract 120, subtract 108, we get 72. So, we have 72 degrees. And what I can do is find out what each, well, if I know that one student is worth 12 degrees, I can find out the number of students for each using the angles given. So, for example, if I do 60 divided by 12, I get 5. If I do 120 divided by 12, I get 10. So 10 students swim. If I do 72 divided by 12, I get 6. And if I do 108 divided by 12, I get 9. Part B, complete the pie chart for group A. So, to complete the pie chart for group A, diving is already done, so now for swimming I need to do 10 degrees. So here's my protractor, and then the 120 degrees takes me up to here. And then I've got 72 degrees. So if I show where 72 degrees is, then so if I do 72 degrees, for paddleboarding, so 72 degrees is up to here. So I've got, here is my completed pie chart with the required angles. Now, one student in Group A changes activity. There is now a new model for Group A. We have to write down the student's original activity and the new activity. So, how could we think about this? Well, what was the mode before? That's the one with the most students, which is, of course, swimming. So the original activity is swimming. So let's think about what the new activity will be. So for the new activity, okay, let's look at what actually happens. One student changes activity. So swimming is reduced by 1, and then there's a new mode. So if I now change swimming to 9, one of these has to go somewhere else. Now, if I increase driving, that turns it into 6. It's not the mode. If I change paddleboarding to 7, that's not the mode. Whereas if I change kayaking to 10, so the student leaves swimming and joins kayaking, that means my new mode is kayaking. Part D. The choices made by Group B are shown in this pie chart. A teacher thinks more students chose driving in Group B than in Group A. Now, we have to give a reason why the teacher may be wrong. Well, we don't know what this angle represents because we don't know the frequencies. In Group A, we knew the frequencies, whereas in Group B, we did not know the frequencies. So the pie chart shows proportions, not frequencies. Question number 9. The length A of a pencil is 15.3 centimeters. To correct to one decimal place, we have to complete the error interval for the length of the pencil. Well, what we have to do is take this 15.3 and then we add and subtract 0.05, which is half of the 0.1 because we're dealing with one decimal place. So for my lower bound, I've got 15.3 subtract 0.05, which is 15.25, and then I've got 15.3 plus 0.05, which is 15.35. Question 10. 4 people take 3 hours to paint a fence. Assume that all people paint at the same rate. Part A, how long would it take one of these people to paint the same fence? So I've got 4 people who take 3 hours. So to find out how long one person takes, well, if here I divide by 4, what I need to do here is times by 4, because they take 4 times longer for one person, which is 12 hours. Part B, how long would it take 5 people to paint the same fence? Give it hours and hours and minutes. So, if one person takes 12 hours, that means 5 people will take 5 times less. So if here I times by 5, what I need to do here is divide by 5. So 12 divided by 5, that's 2.4, so I have 2.4 hours. So, now that I've got 2.4 hours, I need to convert that into hours and minutes. So, 2.4 hours, well, of course I'd have the 2 hours, and then I've got this 0.4 hours, and the 0.4 hours, if I multiply that by 60, that converts it into minutes. So I have 2 hours, 24 minutes. So I have 2 hours and 24 minutes. Question 11. A recipe for flapjacks only uses oats, butter and syrup in the ratio 3 to 2 to 1. Pirin makes 1.5 kilograms of flapjacks. He uses 600 grams of butter. Has Pirin followed this recipe? Show how you decide. So, we've got this ratio 3 to 2 to 1, and altogether we've got 1500. Now we've got 1, 2, 3, 4, 5, 6 parts. So if I do 1500 grams divided by 6, that's 250. So I have 250 per part. So how many do I have for oats? 250 times 3 is 750. 250 times 2 is 500. Syrup, that's just going to equal 250. So, in this question he uses 600 grams of butter. How much does he actually need to use? He needs to use 500 grams. So because this 500 grams, which is what's required, does not equal this 600, what we can therefore say is he's not followed the recipe. Now for part B, using this recipe, 200 grams of syrup are needed to make 10 flapjacks. We have to find the mass of oats needed to make 15 of these flapjacks. So, using this recipe, 200 grams of syrup are needed to make 10 flapjacks. We have to find the mass of oats needed to make 15 of these flapjacks. So, for 10 flapjacks, we know we need 200 grams of syrup. And if I think about this ratio of oats to butter to syrup, I've got 3 to 2 to 1. So to find out how much oats I need to multiply syrup by 3. So if I do 200 times 3, I get 600. So I require 600 grams of oats for 10 flapjacks. So for 15 flapjacks, I take this 600 grams, and from 10 to 15 I multiply by 1.5. So I multiply 600 by 1.5, giving me 900 grams of oats. So we have 900 grams. Question number 12. Part A. PQ is equal to 3, 4. We have to work out 5 times PQ. So I've got 5 multiplied by the vector 3, 4. And if I work out this, I've got 5 times by 3, which is 15. 5 times 4, which is 20. So I end up with the vector 15, 20. Part B. We have to find the value of H and K. Well, I've got H, 5 plus 2K subtract 3, 3 equals 0, 0. So what we'll do is we'll deal with the top row first. I've got H plus 2 subtract 3 equals 0. So I've got H subtract 1 equals 0. So therefore I'm left with H equals 1. And then I've got 5 plus K subtract 3 equals 0. 5 subtract 3, that's 2. So I've got K plus 2 equals 0, which means K equals negative 2. So I've got KH equals 1, K equals negative 2. Part C. Triangle ABC is drawn on the coordinate grid. AB is equal to 0, negative 8. For the first part, we have to use the diagram to complete this vector sum. So we've got AB plus BC plus CA. So we've got what AB is, that's 0, negative 8, and then we've got B to C. What is B to C? Well, we go 6 across and 0 up. So the vector BC is 6, 0, plus CA. To go from C to A, we go 6 to the left and 8 up. So we have negative 6, 8. And if I work this out, 0 plus 6 subtract 6 is 0. Negative 8 plus 0 plus 8 is 0. Next, we have to give a reason why the answer to the sum could be written down without doing any working. Well, we go from A to B, and then B to C, and then C to A. So the point is we return back to the starting point. So we return to the starting point. Question 13. In this question, assume all dimensions are in centimetres. Jess and Pete have many rectangular tiles. Each tile has length A plus B and width 2B, that's shown in this diagram. Part A, Jess joins 3 tiles together to make a larger rectangle as shown. For the first part, we have to write an expression for the perimeter of her rectangle, give your answer in its simplest form. So, what we have is this situation here where we've got a cross for the length, A plus B, and for the width we have 2B. So therefore, for the perimeter, what we have is 6 lots of this A plus B plus 2 lots of 2b. So we have 6a plus 6b plus 4b. Altogether, I have 6a plus 10b, and if I was to simplify this, factorising out a 2, I have 2 multiplied by 3a plus 5b. An expression for the area of her rectangle is 6ab plus 6b squared. We have to factorise this fully. Well, what's the highest common factor of the numbers? That's 6. A is not common to both, but one of those b's is common to both, so my highest common factor is 6b, and what I multiply this by is a plus b. 6b multiplied by a plus b gives 6ab plus 6b squared. Part B, Pete joined some tiles together to make a different rectangle. The area of his rectangle is 8ab plus 8b squared. We have to draw a possible arrangement of tiles for Pete's rectangle. Write down expressions for the length and for the width of the rectangle. So the way to think about this is, think about this rectangle that already exists. What we have currently for this rectangle here is 2b multiplied by 3 lots of a plus b. So, if I write that down, I've got 3 lots of a plus b multiplied by 2b. 3 times by the 2 gives the 6, and then I've got a times by b, that gives the ab, and then I've got b times by b, which gives the b squared. And of course I'm still multiplying them by 6. Now that gets me 6ab plus 6b squared. But what happens if I change this to a 4? Well, if I do that, what I'll end up with is 4 times by 2, which is 8. Then I've got a times by b, so that's ab. And then I add on to this, well, I've got the 4 times by the 2, which is 8. And then I've got b times by b, which is b squared. So that's how we arrange our rectangle. We arrange our rectangle such that we've got 4 lots of a plus b times by 2b. So, let's represent this on a diagram. So, here is our diagram representing this. We've got 4 lots of a plus b for the length, and for the width we've got 2b. So, what is my length? Well, I've got 4 times by a plus b, so that's 4a plus 4b, and for the width I've got 2b. Question number 14. Here are the first 4 terms of a sequence. We have to write down the next term. Well, what am I doing to go from one term to the next? Well, to go from the 6 to the 10, I add 4, 10 to the 14, I add 4, 14 to the 18, I add 4. So if I add 4 again to 18, I get 22. So the next term is 22. Now we have to find the nth term. So for the nth term, well, what I need to do is find the 0th term, and for that, I need to subtract for the opposite of plus 4. And that gets me 2. So for my nth term, I have 4n plus 2. Part C, explained by 511, is not a term in the sequence. Now if I set this expression of 4n plus 2 equal to the 511, let's solve for n. I've got 511, subtract 2, and if I divide that by 4, I get as a decimal for n 127.25. So we have n 127.25, which is not a whole number, so the 511 is not part of the sequence. Now we have to find the term in the sequence that is nearest to 511. So what we need to do here is try find a value of n. So 511 clearly doesn't work. What we need essentially is an even number. So what we'll do here is we will try 510. So I've got 510 equals 4n plus 2. Subtracting 2 from both sides, 4n is equal to 508, which means if I divide by 4, n is 127. So the term that's nearest to 511, well, that's the 127th term. So we have the 127th term. Question 15. In August, the price of a holiday is £500. In August, the price increases by 25%. In September, the price drops to £500 again. We have to work out the percentage decrease from the August price to the September price. So what we can do is find out the price in August. In August, the price is given by 500 multiplied by 1.25. So if I work out what this is, and this 1.25 comes from a increase in 25%, that's 625. Now in September, the price goes back to 500. What we need to do is find the percentage decrease. So to work out the percentage decrease, I have 625 subtract 500 divided by my original amount of 625, and then I multiply this by 100. So if I do 625 subtract 500 and then divide by 625, I get 20%. So I've got 20%. Question 16. Here is a right-angled triangle. What we have to do is work out the value of x. Now here we have to use Pythagoras. So I've got x squared plus 5.25 squared, and this is equal to 18.75 squared. So what we can do is find out what x squared is equal to. So I've got 18.75 squared, subtract 5.25 squared, that's 324. So to find out what x is, I need to square root, and therefore x is equal to 18. Question number 17. Ping chooses 4 numbers. The mode of these 4 numbers is 8, the range is 7, and the mean is 11. We have to find Ping's 4 numbers. So mode means most common. So the most common number is 8. So if the mode is 8, that means that we have at least 2 8s. Now what happens if all numbers are 8? well, the mean won't equal 11, so I can't have 4 8s. What happens if I have 3 8s? Well, I want the range to be 7, so if I work out the range, in this case, how do I work out the range? That's the biggest take away smallest, so I have the biggest number take away the smallest number, 8, say, that's equal to 7. Now why is it that 8 will be the smallest number? That's because the mean is 11, so my other number needs to be greater than 8 essentially. So my biggest number in this case is 15. 7 plus 8 is 15. So if I have my numbers 8, 8, 8, 15, is the mean 11 then in this case? Well, no, because if I do 8 plus 8 plus 8 plus 15, I get 39, and if I divide that by 4, I get 9.75. So the mean in that case is not 11. So that means I should have 2 8s. So to work out the mean, I need to add all my numbers together and divide by how many numbers there are. So I've got 8 plus 8 plus x plus 15. X is my other number, and if I divide all this by 4, I get 11. So, what do I have here? I've got 8 plus 8 plus 15, which is 31. So I've got 31 plus x over 4 equals 11. So what I can do is find out what x is, my other number. So if I do 4 times 11 and then subtract 31, my other number is 13. So for my 4 numbers, what do I have then? Well, I've got the 8, 8, 13, and 15. Question 18. A box contains only red, blue, and green pens. The ratio of red pens to blue pens is 5 to 9. The ratio of blue pens to green pens is 1 to 4. We have to calculate the percentage of pens that are blue. So we've got red, blue, and green. Now I've got the ratio of red to blue being 5 to 9. Then I've got the ratio of blue to green being 1 to 4. What I want is for the blues to be the same to find the ratio of red to blue to green. So, to find the lowest common multiple of 1 and 9, well, that's going to be 9. How do I go from the 9 to the 9? Well, I multiply by 1. How do I go from 1 to 9? Well, I multiply by 9. So here 5 times 1 is 5. 4 times 9 is 36. So the ratio red to blue to green is 5 to 9 to 36. The total is 5 plus 9 plus 36. So if I work out what this is, I have a total of 50. So therefore, for the percentage that are blue, I've got 9 over 50. And if I multiply this by 100, I get 18%. So I have 18%. Question number 19. Asha worked out 326.8 times, and then in brackets 6.94 subtract 3.4 all over 59.4. She got an answer of 19.5. correct to 3 significant figures. We have to write each number to one significant figure to decide if Ash's answer is reasonable. So, writing each number to one significant figure, here 326.8 to one significant figure is 300. And then multiply this by, well, here I've got 6.94, so that's approximately 7. And then the 3.4 will run that down to 3. And then I divide all of this by 59.4, so that's approximately 60. So, if I work out what this is equal to, I've got 300 multiplied by 7 subtract 3 over 60, which is 20. That is quite close to the 19.5. So therefore, her answer is reasonable. And that's because 19.5 is close to 20. Question 20, part A, we have to show that a to the 5 times a to the 3 squared can be written as a to the 11. So what is all of this equivalent to? Well, I've got a to the 5, and then here I've got a to the 3 times a to the 3, that's the same as a to the squared, so that's a to the 3 times by 2. So I've got a to the 5 times a to the 6. So I have a to the 5 plus 6, which is a to the 7. Rather, 5 plus 6 is 11. Part B, we have to write 1 over 125 times 25 to the 9 as a power of 5. Well, 125 is the same as 5 cubed. So I've got 1 over 5 cubed, and then I multiply this by 25 to the 9. So here, 25, that's the same as 5 squared. I've got 5 squared to the 9. So I've got 5 to the negative 3 multiplied by 5 to the 2 times by 9. So I've got 5 to the negative 3 multiplied by 5 to the 11. And if I add the powers, I have 5 to the negative 3 plus 11. So if I work, well, 2 times by 9 is 18. So here I end up with 5 to the power of 15. So, question 21, we've got the diagram which shows below 2 triangles. We have to prove that triangle ABC is congruent to triangle ACD. Congruent means the same. So, how do we do this? Well, let's first of all work out the missing angles. We've got this angle here, which we need to work out. That's the angle BCA. That's equal to 180 subtract 80 subtract 56, which is 44. And then we've got this angle here, the angle ACD. So that's equal to 180 subtract 80 subtract 44, which is 56. So this angle is 56 degrees. We've also got this side, AC, which is common to both. So AC is common to both. So what situation do we have here? Well, we've got a situation of angle side angle. So we've got angle, side, angle. And therefore we have our triangles which are congruent. Question 22. Earth and Pluto go around the Sun. Their distance to the Sun varies. The table shows the closest distance that Earth and Pluto get to the Sun. So we've got Earth and Pluto and the distance. Part A, we have to show that the closest distance of Pluto to the Sun is roughly 30 times the closest distance of the Earth to the Sun. So what we need to do is divide these. So what we have here then is 4.44 times 10 to the 9 divided by 1.47 times 10 to the 8. So if I work out what this is, let's use our calculator. We get 30.204, etc., which is approximately 30, and that's what we wanted to show. Part B, give a reason why we cannot use this information to say that the distance of Pluto to the Sun is always 30 times the distance of the Earth to the Sun. So the distance varies, and that's because they don't travel in a circle.